All right, so like in the last video, I highly suggest that you get a piece of loose leaf and write all these questions down because they're really going to help you when you start to do your castle learning assignment. Okay, you can use them as notes, and I just think it'll be really beneficial for you. All right, so now on the last video, remember we talked about a complex fraction, and basically a complex fraction was a fraction divided by a fraction. Well, I don't have one fraction here. I have two. So I do have fractions divided by a fraction. But in the last video, we had just one fraction in the numerator divided by one fraction in the denominator. All right, so we have the two fractions in the numerator. Now let's just look at them for a second. So if I have two fractions being added together, and notice that their denominators are different, wouldn't I have to find a common denominator here? Because that way, if I add these guys, I'm going to end up with one fraction. Okay, so I want to try to get a common denominator. Now, let's think about this if you're not totally following me yet. So I have x and I have a y. So what I want to try to do is, what can I multiply this x by and this y by to get a common denominator? Okay, so watch. So if I multiply this denominator by a y, and then this denominator by an x, do you see now that my common denominator here would be xy, and this one would be xy, common denominator. All right, but don't forget that whatever you do to the denominator, you have to do to the numerator. So this is also going to get multiplied by a y, and this one over here is going to get multiplied by an x. And we've done this before in a different context, but we have done this before. All right, so let's just do this. So I'm going to rewrite the question over here. So now here's my big fraction line, and I'm going to just leave this harmless little fraction that's just minding its own business right there. Okay, let's see what I have in the numerator. So now I know that my common denominator is xy, right? Okay, xy, xy, or you could write yx, it really doesn't matter. Now let's see what we have in the numerator. So in the numerator, oops, thought that was my pointer. I didn't mean to cross that out. So in my numerator, I have 2y plus 3x. Do you see that? Okay, so we are going to write 2y plus 3x. Okay, now let's look at what we have. So this is what we started with on the complex fraction number 1 Edpuzzle. We have one fraction now in the numerator and one fraction now in the denominator. And that's what I was trying to talk about way back in the beginning of this question. Because now we can we can change division to multiplication, and we can flip this second fraction, just like we were doing in complex fraction number 1. All right. So there is my first fraction, keep. I'm going to change that division to multiplication, and I'm going to flip the bottom fraction. So that's going to become xy over 2. Now remember that if you have common factors, anything in the numerator can cancel with anything in the denominator. So this xy and this xy can cancel out. So let me take care of that. So gone, gone. Okay, now, just to draw your attention for a second, you cannot cancel this 2 with this 2 because this is a binomial. These guys are joined together. You could almost think of them like they were in parentheses, okay? So the only way you could cancel this 2 is if actually this 2y and this 3x had a factor of 2. But this 3 doesn't have a factor of 2, so we cannot cancel. Okay, a binomial is different than a monomial. So we cannot cancel them. All right, because these guys are joined together. So then our final answer is just going to be 2y plus 3x that quantity over 2. And there you go. All right, well, this second one is very similar to the first one, except that in both the numerator here and the denominator here, I have 2 fractions. Now, you may not see that those are 2 fractions, but they really are, because this p, if it doesn't have a denominator, we understand that that's a 1. And this t, same thing. All right, so we need to find a common denominator, because if we're going to do that keep, change, flip, we have to have 1 fraction in the numerator, and we need to have 1 fraction in the denominator. Okay, so let's go back. We have to look here, and let's find a common denominator. So hopefully you see that the common denominator for that numerator is going to be s. So the denominator is going to get multiplied by s. And remember, what you do to the denominator, you need to do to the numerator also. So that numerator is going to be multiplied by s, sorry. Okay, let's look at the bottom. So let's look here. What would the common denominator have to be there? So I'm hoping you're saying that that also would be an s. So we multiply the denominator by s, which means we multiply the numerator by s. Okay? All right, so I'm just going to rewrite that question over here to the right. I'm going to keep the big fraction line just like that. And let's look at what we have right here. So I have s now as the denominator. And in the numerator, I have sp or ps, however you want to write it, plus r. Okay? All right, so I have s as my denominator. And in my numerator, I like to go alphabetically. So I'm going to go ps plus r. And then in the denominator, we will also, oops, let me put my pen on there. In the denominator, we're also going to have a common denominator of s. And then in the numerator, st minus r. Okay, and then just remember, we are going to keep the first fraction, change the division to multiplication, and we are going to flip the second fraction. All right, so let me rewrite that on the bottom. So we are going to, again, we're going to keep the first fraction, change to multiplication, and flip the second fraction. Okay, now remember, after we keep, change, flip, let's see if we have any like terms. Remember, those like terms need to be numerator canceled with a denominator. So I do see that I have a common factor of s in both the numerator and the denominator. And I do not have a common factor. Now remember, this is a binomial and this is a binomial. The only way you can cancel a binomial with a binomial is if they are exactly the same. This says ps plus r. This would have to say ps plus r. If this says, and it does, say st minus r, then this has to say st minus r, which it does not. So in that case, remember, when we multiply fractions, we multiply across, and we are just going to have ps plus r, technically, times 1. And then down here, this is technically 1, right? Because these guys cancel out and become a 1. It's like 5 over 5 becomes 1. And multiply by that. Okay, so that is going to give us st minus r. And there's your answer. Alrighty, well, similar to number 2, you have a complex fraction, but the problem is we want to make this one fraction over one fraction. So if we have 2 fractions and it's separated by a minus sign, or in this case a plus sign, remember, what do we need to do? We need to find a common denominator, right? So I have a b and an a, so, well, those are 2 different variables. So if I multiply by an a here, that would make ab the denominator. And if I multiply by a b here, do you see? That also makes that a denominator of ab. Now remember, what you do to the bottom, you have to do to the top. So I need to multiply by an a here. Okay. Oops, that's supposed to be a parentheses. And I need to multiply by a b here. Okay. Well, how about we look at the denominator of the fraction? Well, we have the same exact variables, don't we? So I could make this common denominator the same as what I just finished doing. So I'm going to multiply by a b here, which means I need a b in the top. And I'm going to multiply by an a here, which means I need an a there as well. All right. So let me rewrite that off to the side. Okay, so let's put the big fraction line there, and let's talk about the numerator here. So if we look at this numerator right up here, do you see that our common denominator is AB? So I have AB as my common denominator. Then let's look at what I have in the numerator. Well, I've got this A times this A, which is A squared, and then I have this B times that B, which is B squared. So I have a squared minus b squared. If we look at the bottom, same thing again. We have a common denominator of ab, and then in the numerator, 1 times b is b, and 1 times a is a. So I'm going to have b plus a over AB. All right, so let's keep change flip. So I'm going to keep the first fraction, and then I am going to flip, and then, change rather, and then I'm going to flip. So AB over B minus A. All right, so this looks great, except that hopefully you're noticing something here. What can you do with this? Hopefully you're seeing that you have dots. So I'm going to do A minus B times A plus B over AB times AB over B minus A. Okay, ooh, Miss Carter made a big mistake. Who can figure out what mistake Miss Carter made? All right, I'm going to put it in a different color so that you can see it. Actually, I'll put it in blue. Okay, look at this. What is that? That's a plus sign, isn't it? Where in the world did this come from? Exactly. Miss Carter's losing her mind. The quarantine is making her lose her mind. That should be a plus sign, which means then this should be a plus sign, which means then this should be a plus sign. So sorry, don't mean to confuse you. Okay, so while we're at it though, let's look at common factors. So I see that this denominator and this numerator are the same, so I can cancel those guys out. And this is why I realized that I made a mistake, because b plus a and a plus b, those are common factors, right? Even though they're written backwards, remember I said this in the other video, 2 plus 3 and 3 plus 2 are still 5 any way you write them. Addition is what we call commutative, so it doesn't matter in what order these letters are written. If there's an addition sign in between, we are good to go. So adios, those are gone. Okay, so now we're just going to multiply across, right? Because when we multiply fractions, we multiply across. And so final answer is going to be A minus B. Technically over 1, but you don't need to write that. Okay, so we have complex fraction again, but the problem is we do have one fraction in the numerator. That's great, but we have 2 fractions here in the denominator. Not so great. So let's put this over 1, and let's talk about the common denominator here. So we have 1, and we have an x plus 2. So all I'm going to do is ask myself, well, what do I have to multiply this 1 by to get it to say x plus 2? And hopefully you realize that that would just be an x plus 2. So I'm going to put an x plus 2 here, and an x plus 2 in the numerator as well. Okay? All right. So let's just move along to the right-hand side over here. So again, that numerator, it's one fraction. That's not a problem. We can leave that as is. All right. So we now know that the common denominator in the denominator is x plus 2. Right? Here's my x plus 2 and here's my x plus 2. Now let's look at the numerator here. I have 1 times x plus 2, which is really just x plus 2, right? Minus x. I'm just going to write that down. I know some of you probably already know that you can simplify that, but you know, let's just write it down so we see it. So we have x plus 2 on the left, right? Minus x. Okay, so let's talk about that for a minute. Do you see that I have a positive x here and a negative x here? So basically, x minus x, that's going to cancel out, and all you'll be left with is 2 in the numerator. So I am just going to make our life a little bit easier and get rid of those guys. Okay? All right, now if you look at this, we do have one fraction divided by one fraction there. We can do keep, change, flip. All right, so let's do that. So my keep is the x over x plus 2. Change, we're going to change that division to multiplication. And let's flip that second fraction. And just a reminder again, these x's canceled out. So we have 2 over x plus 2. That's what we're going to be flipping. So 2 over x plus 2, when I flip that, is x plus 2 over 2. Okay. Now, remember when you're multiplying fractions, you want to look for any like terms. Always cross out numerator with a denominator. So that's gone, and we have a final answer of x in the numerator and 2 in the denominator.